So today's lesson is 1.2, operations with real numbers. So we're just going to talk a little bit about some of the rules when it comes to adding, subtracting, multiplying, and dividing with our two different signs. So our two different signs are obviously positive numbers and negative numbers, okay? So when we are adding numbers, okay, if I am adding two positive numbers, what will my result always be? Positive, good. Doesn't matter what those numbers may be. If they are both positive, your answer will always be positive. Okay. And I'm just putting them in parentheses to distinguish them between the signs outside of them. So that's why I'm using parentheses, just a heads up. Okay, what if I am adding a negative number with another negative number?
Positive.
When I'm adding,
If you're adding two negative numbers, you get positive.
no, it's negative. I think you guys are thinking of multiplication.
Yeah.
That's why I was like, adding? So I appreciate the confidence, but so if you were adding like -3 with -4, the answer would still be negative, okay? What about if I'm adding a positive number with a negative number?
Depends on the number.
It depends, okay? It does depend. Okay, it depends on which number is going to have the better value from 0. Okay. All right, so we have our adding rules. Okay, what about subtracting? If I have a positive number and I subtract another positive number, is there a guarantee that it will be positive or negative? No, right? It depends. It depends on how big the numbers are, right? If I'm having 80 minus 60, that's fine. But if I have like 5 minus 8, that's going to change things, even though it's, okay, so it depends. What about negative? If I have a negative minus a negative, is that necessarily always true? Not really. So subtraction is actually the weird one. Subtraction will literally always depend on what you're working with. Okay, there's never going to be a guarantee with subtraction that you will have a positive nor negative number. Okay, even if it's a positive and a negative. Okay, but what happens when you have a double negative? It does make a positive. Okay, so when I have negative minus a negative, right, a double negative becomes positive. Still depends, right? I still have positive and a negative. But what happens when you have a positive minus a negative? What happens with the double negative? Again, it turns positive. So in this case, it's going to be positive. And this might be a little confusing right now. Once we get to actual numbers, it'll probably help a little bit out. Just trying to help with some rules to begin with. All right, now let's talk about multiplying, which is kind of where you guys went with to begin with. Okay, what happens with multiplying rules? So if I have a positive times a positive, what will the result be? I have positive, right? Always will be positive. I have +3 times +8, it will always be positive. Okay. Now, what about that negative times a negative? Negative times a negative is a positive. That was the one you guys were like gung-ho on earlier. Okay, and last but not least, what about a positive times a negative? A negative. And last but not least, dividing. I guess I could. I have a positive number divided by a positive number. What will my result be? I have 3 divided by 4. Is that gonna become negative all of a sudden? No. What about negatives? I have a negative divided by a negative. What happens? I have -3 divided by -4. What happens when you have a negative divided by a negative? Positive. Okay, so that rule is similar to the negative times negative rule. Okay, when you have 2 negatives and you're multiplying or dividing, it turns positive. Okay, last but not least, a positive divided by a negative, or a negative divided by a positive. Either way, when you have 2, 1 of each, what will the answer always be? TJ? Not TJ, sorry, TL. Negative, yes. Okay, so at the end of the day, there's really only 3 of them that kind of depends on what you're working with. Everything else kind of has a set rule, okay? So what we're gonna be doing today is we're gonna be practicing we'll do a couple, we're gonna practice with the decimals and fractions, okay? It is under our assumption that once you come to 8th grade, or if you're in 9th grade, depending on what grade you're in, that you should know how to add, subtract, multiply, and divide regular numbers, okay? So that's why we're gonna focus on decimals and fractions. We still assume you know that, but those are typically more difficult, so that's what we're gonna focus on. So I'm not gonna be starting off with like 3 plus 5, okay? I assume you know that. We don't need to practice that. Okay, so we're gonna practice with decimals. Okay, 5.4 plus 1.7. Okay, now most students typically do not like writing these types of problems horizontally, but it might be provided to you horizontally, okay? How else could I write this that might make it a little bit easier for you? Vertically, right? Doesn't matter that I rewrite it, totally fine. Now, when I add it, it is important that you line up your numbers. So the right side should be even, they're lined up. Sometimes the numbers are different. They don't necessarily always perfectly line up, but the right side should be perfectly lined up. Okay, and then we just add down. So 4 plus 7, 11. We put the
What?
1.
What?
Okay, and 1 plus 5 plus 1 is 7. Now, how do we know where the decimals? Yes, Maddie?
What the second minus thing is, because
I will help you in just a second, okay? One second, I'm trying to find. Where'd my mouse go? There it is. Come over.
is that the box?
Oh, there it is. I was trying to get to come back to my screen. There we go. Thank you. I kept doing this, but it wasn't moving. Okay, so how do we know where the decimal goes? We bring this straight down, okay? So that will change later when we're doing multiplying, but with adding, you just bring it straight down. So the answer is 7.1, okay? When you're doing your work, I always prefer if you like box your answer, circle your answer, one of those things. I've had students in the past highlight them. I've had students like use a colored pencil or something to outline it. However you want to make sure, huh? Well, you probably shouldn't answer in pen because you grade in pen. So that's why we do our homework in pencil. So if we make mistakes, we can erase. But if you do your homework in pen, then you need to grade it a different color. So, but preferably you're doing it with pencil. Okay, so that's our answer for number 1. Again, like I said, you just need to showcase what your answer. Box, circle, I don't care, star, oval, trapezoid, whatever you want, I don't care. Okay, make sure it's obvious though. Okay, 14.5 plus a negative 4.3. 14 plus 5 plus a negative 4.3. Okay, and so the reason why I put parentheses around this is just so you can identify it as a negative number. Okay, what happens when you're adding with two different signs? Well, it depends, right? We don't know, but we do know that we need to find are we actually adding these two together when they have two different signs? No. So when you have two different signs, you got to find the difference. And then depending on the numbers, you'll know if it's positive or negative. Okay, so rather than writing this as an addition problem, can I write this as a subtraction problem?
Yeah.
Yeah, so instead of writing 14.5 plus a negative, instead I could put 14.5 minus 4.3. Okay. So it gives us another option to make it a little easier on us. Now, like I said, on the first one, the right side needs to line up, but as you can tell, my 1 doesn't have anything under it, and that's okay. You'll notice what happens there in just a sec. So 5 minus 3, 2, bring down the decimal. 4 minus 4.
0.
Now, what am I subtracting from 1?
1 minus
1 minus 0. So if there's nothing there, it's like you're taking away nothing. So 1 minus 0 is 1. So we get 10.2. Right? So again, it's important that the right side lines up. If there's extra numbers on the left, it's just like you're subtracting 0. Okay? If you ever get to a point where you're confused, just let me know if I'm going too quickly. And Maddie, we will talk about what that is later. So that's why I said I'll help in just a sec once we talk about it again. All right, number 3, negative 4.9 minus 0.4. Negative 4.9 minus 0.4. Okay. Now, it is a subtraction problem, but they're both negative. So what happens when both terms are negative? There were a lot of answers coming out there. You add them together. So if they're the same sign, you add them together. Will the result be positive? No, it'll still be negative, but because they're the same sign, we combine them together. So get negative 4.9 and negative 0.4, but since we're adding them, we're just going to treat it like an addition problem here. Combine them. 9 and 4 give us 13, which gives us 1 and 4, which is 5. Bring down the decimal and put that negative back on there. Negative 5.3. Okay, we're gonna go ahead and do one more with decimals, and we're gonna move on to some fractions. Okay, number 4, 1.81 minus 17.17. And I'm gonna go ahead and let you try that one on your own. That is the perks of using pencil. You can erase if something goes wrong, but I want you to try number 4 on your own. 1.81 minus 17.17. All right, go ahead and share with someone near you what you got or what you think it is, or hey, I need help. One option. Dominic, feel free to join in with them. Okay, go ahead and wrap up that conversation. Okay, what does anyone want to offer up their answer? Yep.
Okay, so I think it's 17.7 minus 1.8. You can't do this on a zero. You have to put that. That was 3 or 3. I mean, 11 minus 8 is 3. Then put the rest of that. 7 minus 1, which is 6.
I'm gonna say that once more, just so it's a little easier up here. So because they're opposite signs, that means we need to find the difference between the two of them. And in this type of problem, it is going to be easier to subtract the smaller valued number, which is the one that's closer to 0. So rather than trying to subtract, it's going to make it a little bit more complicated. So we're just going to switch the signs real quick. Okay, so 7 minus 1 is 6.
Like 1.18 minus 17.7. Is that what it is? I mean, I don't understand.
So I'm saying because, and rather than subtracting the number that's farther from 0 and making it a little more complicated for yourself, it's going to be easier to switch the order and say the bigger one minus the 1.81. And then remember that the answer should still be negative in the end. If you have a different way of doing it, feel free to let me know and I can let you know if that works as well. So I'm gonna, yeah, I did. I switched them. That's what I was saying.
You put the bigger number on top, you can't do 1.8 minus 17.
It will make it easier in the end. If you want to do it the other way, that's fine. But most cases, students find this process easier to do it this way, to switch it.
How are they negative? I don't
Something's negative versus subtraction.
You're just subtracting.
understand. You said the answer's still negative.
The answer will be negative because this number is further away from 0. So when you are finding the difference, the value would still be below 0. So therefore it would be negative. Okay, let me keep going and see if that helps. So from here, 1 minus 8, we can't do that. So borrow from the 7. We get a 3, 5, and 1, and bring it down. Okay, now, again, the 17.17 was negative to begin with, and that was the further from 0. So we know in the end, my final answer should be negative, okay? If that process doesn't work with your brain and that doesn't make sense, I'm happy to explain it a different way. Most students find this process a little easier this way. There is a different way, and I'm happy to help anyone that needs that, okay? What? Almost got it right? Okay, well, learn from our mistakes. That's the biggest part. Okay, let's practice with some fractions. I don't write on the backs because it smears. for me? Okay. Number 5, 1/5 plus 3/5. Okay, what are the rules when adding fractions? Yes.
You don't add the top.
When what? When what is true? You only add the top when what is true? When the denominators are the same. Good. So when you have common denominators, you only add the numerators. You only add the top. Okay. If you need to write that note to yourself, feel free.
What are they called?
So the top is numerators, the bottom are denominators. When the denominators are the same, or another phrase is common denominators, if they're the same, you add the top 2 numbers together. Or you can subtract the top 2 numbers, but if the bottoms are the same, you can add or subtract across the top. So in this case, 1 plus 3 is 4, so we get an answer of 4/5. You're going to leave your answer as a fraction. Okay, how about number 6? 3/4 plus 2/4. 3/4 plus 2/4. Because we have a common denominator, we can add the tops. So we get 3 plus 2, 5/4. Should this be my final answer?
In a form of fraction. Yes, it's a.
Trick question. This is the final answer. Yes. We do not do mixed numbers at Sumner because once you get higher in math, mixed numbers make the math much more complicated than just using improper fractions. Okay. So a mixed number and an improper fraction, that's not necessarily simplifying. And I never know why middle school teachers teach it like it's simplifying. It's not simplifying, it's just writing it in a different way. Okay. So at Sumner, improper fractions is what we would like to see, not mixed numbers. Okay, so do not write as a mixed number. Okay. Is it the same number? Yes. But again, as we go on, especially topics in algebra and beyond, it doesn't make sense to use mixed numbers. And so then it just makes it more complicated when students are only thinking about mixed numbers. So rewire your brain to improper. Yeah. You got to fill out a pass. Say yes. Okay, try number 7. How about 3/2 plus 1/2? Go ahead and try that one on your own. 3/2 plus 1/2. Right, what should we get when we add those across? 4/2. Now, should this one simplify? Yes. Because it divides evenly, we should simplify it. On the previous one, that wouldn't divide evenly, which results in the mixed number. If it divides evenly, you should simplify it. Okay? If it does not divide evenly, leave it as improper. If it divides evenly, simplify it further. Okay, now let's do some subtraction. We're going to go ahead and use the same numbers, but subtract it. 3/4. So 3/2 minus 1/2. Three halves minus 1/2. So we end up with final answer, yes. So we would get 2/2, which simplifies to 1. Good job. All right, last subtraction one. Well, last common denominator subtraction one. 7/6 minus a negative 5, 6. 7, 6 minus a negative 5, 6. And this is where it comes into that thing we talked about earlier that comes up. And I'll let you write it down and then I'll show you the front page again. So this is that weird case when you get a double negative effect, where you have a subtracting a negative or a negative negative, okay? When you do that, it becomes that positive value, okay? Anytime you have a subtraction of a negative, it becomes positive. So anytime you have a subtraction of a negative, it equals positive. Okay, it's essentially like saying you are doing a like a double negative turns positive. So in that sense, we're actually an addition problem. So we get 7, 6 plus 5, 6, which equals 12, 6. Which can be simplified to 2. Okay, now let's put in those non-common denominators. Let's talk about those. 1/3 plus 3/8. 1/3 plus 3/8. Right, so a little bit more difficult, but not insanely more difficult. What? We're on the second lesson. It's not that. Okay, so we do need to find a common denominator. So what is my common denominator between 3 and 8? 24. So that means we're going to multiply the first fraction by 8/8. We're going to multiply the second fraction by 3/3. Your goal is to multiply by the number to get you to the common denominator. So if my common denominator is 24, that means I got to multiply by 8. Opposite would be multiplying by 3. What will be my new fraction that comes from that?
8/24 plus 9.
Good. So by multiplying both of them to get that common denominator, now what can we do? We can just add or subtract across the numerator, across the top. So 8/24 plus 9/24 give us 17/24. Okay. The biggest thing I will say, because I know a couple years, I say it as a fraction. So I'll say like 1/2, 2/3, that kind of stuff. The biggest thing is just don't say over. Okay. So don't say 17/24, because over is not a math word. You can say 17 divided by 24, or you can say 17/24 with the TH at the end. Okay. So please don't say over, because that's not a math word. Okay. Try and rid 8th graders of that word. Over, flip, those aren't math words. All right, let's try another one. 2/5 plus 3/10. What was the last one you worked on, Maria?
7.
All right, I just didn't want to make sure it was visible. Okay. Try number 11, 2/5 plus 3/10. You want to create a common denominator, so therefore you can add across. If you're not sure, just think about it, try something. Shannon. Is it going to be a quick one, or is it going to be there with you? I just didn't know if it would be easier to send them at the end than to send them early. Yeah. I just figured it'd be easier than him having to come back up again. Okay, thank you. Okay, in this problem, how would we create a common denominator?
8. Let's do 5 times 2, which equals 10. You don't have to do it to the other one.
Good. So with this problem, a common denominator between the two could be 50. You could multiply both and get 50, right? But isn't a 5 a factor of 10?
Yes.
Yeah, so therefore I actually don't have to multiply both. I can just multiply the 1 by 2/2, which gives me 4/10. And that 4, I don't have to change the second one, okay? If you want to multiply it to get to 50, that's fine. You're just going to have to do more simplifying in the end, okay? But there are cases where you do not have to, like that one. 7/10 is the final answer, correct? Okay, so one more fraction one. Well, that's what paper's for. -4/3 plus 3/2. -4/3 plus 3/2. So technically the whole number is negative, but when you are adding across the top, you would treat it as a -4. So right now your main focus is just creating common denominator. Once you do, then you'll treat that negative as part of the answer as well, okay? So good question. Again, I'd like you to try number 12. This is how you learn. You practice it on your own. You see what you get. If you get it correct, you know you're on the right path. If you're not getting it correct, you know you need to ask questions, ask for help, seek advice. Okay, share with someone near you what you think that answer should be. Okay, wrap up those conversations. We'll go over it together. Okay, so what should be the common denominator between these two terms? 6. So we're gonna multiply the first one by 2/2 and the second one by 3/3. So we get -8/6 plus 9/6. Okay, because the denominators are the same, that means I can add across the top. So that's -8 plus 9, which results in a value of 1. So our answer should be 1/6. -8 plus 9. They're opposite signs, so we find the difference, which is 1. And it's all good. All right, questions and concerns for number 12. Okay, guys, let's move on. Okay, adding and subtracting is probably the hardest thing to do with fractions and decimals. Multiplying and dividing, typically a lot easier. We're only gonna do 4 more problems. We're going a little later than normal because it took us a lot longer to grade. Normally we would not be going this late. Yes, Maddie.
And writing down problems, they don't understand.
Okay, let me write down the next one and I'll come over and help you, okay? All right, number 13, 3.2 times 0.41. 3.2 times 0.41. We did some multiplying of decimals yesterday and Monday. So you should be good to multiply these. Should be a review from Monday and Wednesday. We multiplied decimals. So practice that, yeah. You gotta do a pass, but yes. And I'll be right back with you.
Oh my gosh. It's the hesitation. And then count 1, 2, 3. So it's 1 point.
Yes.
Okay, what? So you don't. You're not. You're multiplying like to the next number. Not necessarily the same. That's why I was like, oh, it's not crossing. Okay, so you can do 1 times 2. You know how to do 2. And 1 times 3 goes. You need a certain. So you get certain. Yeah, but the decimal goes right here. That's not my. The flow. Look at this. It's 1, 2, 3. That's like. 1, 2, 3. There's nothing.
I guess I need to put my name up on the board. It's right here. You know, sick kid at home. I'm never gonna have a chance. Okay, let's see what we get. 3.2 times. Curve the discussions, please, for me. Okay. So right side has to be lined up in order for it to work. It's not showing up on my side, but can you show me your computer? That's still not my name. I don't know. I don't know what happened. All right, so we start with the bottom right corner. So 1 times 2 is 2. 1 times 3, thank you guys. I didn't mean to cut you guys off, is 3. Okay, then we go down to the next, so we put a 0. Then we do 4 times 2, which is 8. 4 times 3, which is 12. Okay. And then we add down. So we have 2, 11, 3, and 1. How do I know where the decimals go on this type of problem? Yes.
So what you have to do is you have to count the numbers.
I'm sorry,
behind.
1 second. Can we have some silence, please? Guys, we should not be talking right now. Okay, I said curb the discussions because I was starting to talk so that everyone could hear me. And now we have a classmate trying to explain as well. So talking over me, disrespectful, talking over them, 100% disrespectful, okay? I can take it, I'm an adult, but you should not be talking over your peers, okay? She's gonna answer. So why do we know where the decimal should go?
You know where the decimal should go because what you have to do is count the numbers behind the decimal. So in this case, it's 3 numbers behind the decimal.
Great, so the
More
2,
than 1 and 2.
yeah, the 4, the 1, the 2 are all behind the decimals in the original problem. So that means there needs to be 3 decimals behind in the final answer. So 1.312. Okay. Number 14. Okay, 8.5 divided by 3.4. We're gonna have to go through these a little bit quicker to make sure we get through everything. Again, because the grading kind of just took a little more than expected. Okay, because these are both decimals, we can make this a little easier on ourselves and take out the decimals, okay? But that does affect how our answer is, so let's show how that works. So 8.5 will go on the inside. And 3.4 will go on the inside, or sorry, said that backwards. 8.5 goes on the inside, 3.4 goes on the outside. Because they both are decimals, what I can do is I can kind of move my decimal over and think of it as instead 34. I'm gonna rewrite it, 34 divided by 85. Okay, which makes things a lot easier. The only thing is you have to make sure that you put that negative at, or you put that decimal at the top now. Okay. Now we can think of it as 34. How many times does 34 go into 85? Twice. Iris, can you shut the door, please? Just to feel a little loud. It should be twice. Okay, what is 34 times 2? 68. And then we're going to subtract to find the difference. What's the difference between those two numbers? 17, good. Okay, how many times can 34 go into 17? 0 times, so therefore we need to add that 0. Okay, how many times can 34 go into 170? Close. Not 14. It's 5. Okay. Do the math. I'm not.
170.
34 times 5 is 170, which gives us,
That's that.
so your answer is 0.25. So again, we kind of did some dividing the other day. The biggest thing is when you have decimals, just move it over in the problem and put a decimal at the top to help you out. Okay. 2 more, we're almost there. These are the easier ones. 2/3 times -5/6. 2/3 times -5/6. What are our rules when it comes to multiplying fractions?
You have that common denominator.
Do you have to have a common denominator when multiplying?
No.
No, you just multiply across. So you're gonna multiply numerator to numerator, denominator to denominator. When you're multiplying, so a positive times a negative is still a, positive times a negative is a negative. Positive times a negative is a negative. So 2 times -5 is -10. And 3 times 6 is 18. Okay,
You simplify.
we should simplify. They're both even numbers, so they're at least divisible by 2. What would that simplify to? Be -5/9, correct. Okay, so I'm gonna explain that again because there was a little bit of confusion at the beginning of that one. You do not have to have a common denominator when you are multiplying fractions. You simply multiply the numerators and you multiply the denominators. At that point, then you can simplify. You could have also simplified the 2 and the 6 to begin with if you wanted to, but you don't have to. You can just simplify at the end. All right. Last problem. We're gonna use the same numbers, but we're gonna say divided. 2/3 divided by -5/6. What do we do to divide fractions rather than actually dividing them? Yep,
Find the reciprocal of the second.
good. So a phrase you may have heard in middle school may have been keep, change, flip. Okay, and one of my famous quotes from any students you may have asked is that dolphins flip, fractions don't, they reciprocate. So again, flip and over are not math words, don't use them. Try and use reciprocal or division type words. Okay, so we say 2/3. The division changes to multiplication. -5/6, what does that change to when you reciprocate it? -6/5. So the numerator and denominator just change positions. Once it's like that, you just multiply across like we did on the last one. Okay. So, rather than think of it as keep, change, flip, think of it as keep, change, reciprocal. Does it mean the same thing? Yes. Should you be using math vocabulary? Yes. Okay. So multiply across 2 times -6 is
12.
-12, and 3 times 5,
And
-4/5. Correct.